Well, good afternoon. So I'm Sean Sullivan, and I work for Gilt.com, which is recently, a year ago, we got acquired. We're now part of the Hudson Bay company. But most of what I'll talk about today will reflect on the work we've done at Gilt over the last couple of years. So I write code, and I've been mostly working on the JVM for about 20 years. I've done client-side Java, server-side Java, and for the last 6 years or so, I've been doing primarily Scala coding. Mostly what I work on is back-office systems. That includes things like the checkout business logic, order processing, payment processing, fraud scanning, as well as returns, the RMA data model, and the RMA business logic. So, Hudson Bay has kind of an interesting history. They were a venture capital startup funded way back in 1670. And they've pivoted a couple times over the years. And they actually have kind of a different business now. Originally, they were in the fur trading business, but now it's all about retailing of merchandise. So this is the Hudson Bay store here in Vancouver. And over the last couple years, Hudson Bay has expanded more into the United States. So they've acquired multiple retailers, including Saks Fifth Avenue and Lord & Taylor. And Gilt was the most recent acquisition about a year ago. So at Gilt, one of our main philosophies is that we've embraced microservices, and we really try to encourage API-driven development. We want developers to be thinking about their API as a first-class artifact of what you're building. It's not really a side effect of writing code. The API is what you should be designing early in the project. So what we've embraced in the Gilt code base is the use of API descriptors. And API descriptors are a pretty common idea. They've been around for a long time. I think the first time I encountered API descriptors was back in the 90s. I was trying to teach myself Corba, and I was using Corba IDL to describe a service that I was building. But over the years, SOAP was kind of a popular thing in 2000 and beyond. And then after that, there have been multiple attempts at standardizing API descriptors for RESTful services. Waddle was something that came out of Sun Microsystems in 2006. Didn't really catch on, but I think it served as an inspiration for projects that followed later. So at Gilt, we in about 2014, we started doing a project for ourselves. We called it API Doc originally. And then just 2 weeks ago, API Doc was rebranded, so we now call it API Builder. So API Builder has a brand new website. This just launched as we were rebranding everything 2 weeks ago. And we also moved all the code from a different, it had a different location on GitHub, but the new spot is under what's called API Collective. And there's a lot of sub-projects under API Collective now. But the basic concept is describe your RESTful API through a JSON descriptor file. And the general philosophy is that your descriptor will describe the models of the API. So that might be things that you're sending in a request, or it might be a model that describes what the response is of your service. And then once you have those models defined, then you could do a mapping of relating those model objects to the various resources that you're exposing through HTTP. So this example here, this is actually a project I was working on this summer. We're actually redesigning the way that we manage credit cards internally. And in our world, we store credit cards in a database, and everything has to be PCI compliant. So we have to restrict access to the credit cards. But we also do need to expose an API so that application code in the order processing pipeline can get access to certain information. So this is an example of an API builder descriptor that has a list of fields related to the credit card object. So once you have that set up, you can define the resources in your REST API. So in this case, there's going to be a get operation to get a credit card. And the descriptor describes the response codes, and each response code can have a different return type. So in our scenario, the credit card is usually there, and you'll just get a 200 response with the credit card JSON. But we also handle 404. In practice, that doesn't usually happen, although occasionally things go haywire. But so the thing about my work, I joined Gilt in 2011, and at the time the company's platform was really in transition, and there's a lot that has changed over the last 6 years, and I'll kind of walk you through where we were back then and how we evolved into doing microservices today. If you haven't been to our website, this is a very typical page on our site. We sell a lot of fashion merchandise, be it shoes, dresses, purses, things of that nature. So this page in and of itself, when this page is loading, the request on the back end may trigger a cascade of more requests that are going on behind the scenes. So in our website, we try to personalize everything that the user sees. So we have services on the back end to facilitate personalization. So for example, a user could specify their preferred currency, and then we have a pricing system on the back end that's going to present the localized currency. We also have language localization, and then we have other information about the user and their specific preferences around brands and sizing and things like that. So this page, when it loads, it may call anywhere between 10 or 20 other services on the back end to help render it the way we want it. So in the early days of Gilt, this was about 10 years ago, Gilt was a small startup in Manhattan, and it had a really small engineering group, and they wanted to be able to iterate really rapidly and get prototypes out to production really quickly. And scalability wasn't an issue. The company was so new. They were still getting the word out and telling people to come shop on the site. But in the beginning, it was a Rails app. All the code just lived in one Git repository. And what was interesting about the Rails app in the early days was that it had customer-facing web pages, and it also had web pages that were used internally for customer service and other internal business operations. So it was really like just everything got shoved into this one app. And so if you were deploying a customer-facing change, you'd deploy the Rails app. If you were deploying a web page for internal business users, you'd deploy the same app. And so everything was just bundled together in this big monolithic release or rollback as it might happen. So it actually kind of worked well for Gilt when it was a small company. This allowed the engineering group to iterate really rapidly and get new things out to production quickly. But over time, Gilt was having some trouble scaling the system, and somewhere around 2009, there was an initiative to get the JVM into the company and to start breaking apart the Rails monolith that we had. So as these new backend services were being designed, there was also a web framework that was invented to serve JSPs. It wasn't an off-the-shelf web framework. It was kind of an internal system. But this actually worked well. I mean, this brought Gilt to an era of stability that the company didn't have before. They were able to handle big spikes in traffic much more easily. So at this time period, the services that were being built in Java were things like inventory service, product catalog service, shopping cart service, a user authentication service, things of that nature. And as those backend services were being built, there was a need to have client libraries that were going to call those RESTful services. So developers were kind of like handcrafting these clients. Sometimes they were just copying code from each other, or maybe copying code from Stack Overflow. But in this time frame, these clients had one common feature. They were all weakly typed Java client libraries. And when I say weakly typed, I mean they didn't have Java beans or anything like that. They were primarily just Java hash maps. So they'd make an HTTP call, get a JSON response, feed that JSON response to the Jackson parser, and then Jackson would just dump it all into a Java hash map. So this did move Gilt forward because it got us further away from the Rails code base, but we knew it wasn't exactly where we wanted to be in the long run. So 2011, this is about the time when I joined the company. There was a further initiative to build out more services and to really try to decompose the old Rails app that existed. We wanted to make sure that the Rails app was no longer serving customer-facing pages. And to support that, we were building a lot of back-end services. So about this time, Scala was introduced into the company. So I think it was like summer of 2011. Scala kind of became the default language in our organization. And as Scala was being adopted, there was also an initiative to build better client libraries so that our new user interface would have a better way to fetch data from these backend services. So these new client libraries were going to be strongly typed. They were going to use Scala, and we gave it a name. We called it the Commons library. So internally, this library contained objects in our business domain. So things like what we call a product or a sale, or a SKU, or pricing information, or a user object. Those were all had a common definition in Scala in this library. So we would publish this library to our own internal Maven repo, and all of our services could take advantage of it. So over time, Commons library became larger and larger, and it did make development easy at first. It definitely allowed more code to be shared within the company, and so there was definitely a point between 2013 and 2014 where, developers were really leveraging this shared code really well, and we were able to get a lot more new features into production. So we were both breaking down the old monolith, and we were building new features at the same time. But as the number of services kept growing and growing, we kind of encountered a problem with binary coupling. And this was sort of an artifact of how our development process was set up at the time. But the Commons library had a lot of shared client code. But we had so many services that what we ended up doing was we had each team that owned a service, they were also responsible for publishing a client library. And typically what was happening was your service implementation and your client library implementation were all in one Git repo. And you'd run your build and you'd publish out your artifacts. So you'd publish out your server-side code as an artifact, and you'd publish out your client code as an artifact. And so there were many services doing this. And what was happening was that inadvertently, we just had binary coupling happening. Like nearly every service that was being built, if you were building a service and you had to call 5 other things, well, you had to make sure that those 5 other client libraries that you were calling were all like compiled for the same version of Scala and compiled for the same version of some other libraries that you might care about. And you'd want them all kind of like compiled onto the same thing so that you wouldn't have any runtime problems. So it was sort of like accidental coupling at the binary level. And it reached a point where it just became more and more painful. And we started talking about it as dependency hell. And it was about that time when we realized we needed to do things differently. And that was the early genesis of the API Builder project. So when you do have dependency hell at a large scale, eventually you're going to run into some sort of runtime hell in production. And that definitely happened at Gilt. And when it first started happening, we didn't fully understand the problem, but very quickly we realized that binary coupling was breaking production, and it was causing just all kinds of developer pain, because developers had to figure out how to overcome this runtime hell in their code bases. So the takeaway for us was that it was killing productivity for all our developers, both junior and senior level developers. They didn't want to fight with their dependency chain anymore. And it turns out that Gilt wasn't the only company facing this problem. Netflix had this exact same issue, and one of their engineers, Ben Christensen, gave a presentation. You can find it on YouTube. But Netflix was suffering from binary coupling, and this made it really hard for them to upgrade libraries internally, because everything had this weird binary interdependency. And so Netflix was finding that it was just really hard to roll out new versions of libraries, because everything was like interrelated. And you had to be incredibly diligent about managing your dependencies, and you had to be diligent about figuring out what order you could upgrade things. And that's how you have a really big problem, is if you have so many microservices and you can only make things work by upgrading things in a very well specified order, that can be a problem, and it certainly was at Gilt. So we were trying to figure out how do we mitigate the dependency hell. And we realized we really needed to treat API design as a first-class concern of our development cycle. And we realized that we didn't necessarily need our teams building client libraries. What we needed was a way to just generate client libraries. And so API Builder was really built with that purpose in mind. We knew that we wanted to generate these client libraries, and we wanted the code generators to be incredibly smart and give us lots of choices about what was being generated. So over the last 24 months or so, more services are running in production, and the new services that we've brought online have all had these API descriptors, and we've been able to use code generation to generate the clients, and it's actually helped quite a bit because it decoupled. It put an end to some of the binary coupling that was happening, and in addition, it also reduced the amount of boilerplate code that our developers were writing. We found that developers were having to code all these client libraries by hand, and they were just copying and pasting a lot of boilerplate over the place. And once you realize you're just copying boilerplate code, then maybe code generation is an alternative you should consider. So as code generation became more prevalent in our organization, we kind of treat the Gilt Commons library as kind of like deprecated code. We try to make sure that when we're building a new service, we don't want it depending on this old global library that everything used to depend on. So we treat it as deprecated. We still support it. There's still legacy services that use it, but new code is discouraged from using the Gilt Commons code base. So here's an example of something we did in the last 2 years. We decided to redesign and rebuild the Gilt checkout system. So we have an API that encompasses business logic for the checkout user experience, and this business logic kind of needed to be revisited and modernized. And so what we decided to do was build a whole replacement service for the old checkout. And as we did that, we created an API descriptor for this new checkout API. So under API Builder, the default file name is called api.json. And we've been able to use this to generate clients. We actually now have a Swift code generator, and we were able to generate code that is running now in our iPhone app. There's an Android Java code generator that was built internally and is now open source, and we run that inside of our Android app. And then there's another a web interface. So everything is driven off of the common API descriptor, and this has worked really well for us. So generating these client libraries has always been a goal of the project from day one. And when we started the project, we really wanted, our internal code base was at the time was primarily Java, Scala, and Ruby, because we still had this old Rails app. And as much as we wanted to kill off the old Rails app, it never really got killed off. So it's in maintenance mode, and we still have to keep it going. So we've been able to have code generators to support all the platforms that are important to us. And then we've also had some other contributions out there. There is a Go language generator as well. So if you go to our GitHub page, if you drill down, there's a repo called the generator repo. And inside the generator repo, you'll find a submodule called Scala Generator. And the Scala Generator actually does a lot of things. It's not just designed to output one type of client. We've actually built it to support many flavors of Scala clients. So in the early days of this, we internally at Gilt, we were using the Ning HTTP client. So we wanted to have code generators that would output Scala code that would utilize that old Ning library. And then we also wanted to support PlayWS. So internally, we have lots of projects that use the Play framework, and different teams are on different versions of the Play framework. So we actually have different flavors of the client generator that will output whatever is appropriate for each version of Play. And most of the code is the same, but there's a few minor differences between each version. So the code generator knows what those differences are and just does the right thing for you. And then I think about a month or two ago, one of our developers in Ireland wanted to support HTTP 4S with the Circe JSON library. So you can now just use that and just output a Scala client that runs on those libraries. This slide is really just an example of the Play 2.5 code generator. And pretty much each version of Play that we support, we had to set up a little, what we call a config object for that version of Play. And then the code generator uses that config object to output the right thing. And in fact, Play 2.6 just came out a couple of weeks ago. And I added support for Play 2.6, I think the day after it was released. So, all right, so didn't really want to go to a conclusion yet, but I'm going to go to, oops. So Gilt's not the only company that's using API Builder. There's a startup in the New York City area called Flow Commerce, and they are like an international logistics commerce platform, and they partner with U.S. retailers to help U.S. retailers take their retail shopping experience and make it into an international shopping experience. And so Flow Commerce actually built their whole company with API Builder. And they actually published this public API to the world. And the thing about API Builder is that we think of it not just as a code generation or API descriptor, but it's also a documentation tool. So that developers who want to go look at a public API should be able to go find public documentation. So that's what Flow Commerce ended up doing. They publish their full API online to the world, and then they have various things sprinkled throughout their API documentation. And all of this is driven directly off of the JSON file. So the API Builder website that we're looking at knows how to render those JSON files in a way that looks nice. So I think, I would say Flow Commerce is definitely the best example out there that shows what you can do with this technology. And The thing is, at the project I'm working on at Gilt, we mostly are using API builder descriptors just for internal services. But we have looked at exposing more public APIs, and we're planning to use API builder for that in the future. Okay, I'm going to switch over to I'm going to show you what the generated code looks like. It was generated off of a descriptor. So I was talking about credit cards as being something we're working on this summer. And so we have an API descriptor that includes the model for those credit cards. And there's an enumerated type for designating whether it's a Visa card or a MasterCard or something else. And the Scala Generator, this is the output. Let me blow that up a little further, but this is what you get from our Scala Generator. And the thing is that we decided that our code generator would always add one extra value to your enum set. And we call that the undefined value. And the reason we do that is we wanted to make sure that we could handle, once this client is generated and then some team might put it out into production, everything should be fine until another team comes along and decides they want to add an additional value to the enum. And we actually had this problem at Gilt like 2 years ago, where initially in the early days of Gilt, we did not support union pay. And then we realized, oh, we want to support union pay, of course. So then we started adding it to an enum list that we had way back when. And our server-side code was suddenly outputting union pay values. And at that time, the clients that were running in production didn't know what to do with the union pay value, and they were just blowing up and throwing an exception, which was not what we wanted. We wanted to have we want our client libraries to at least be somewhat forward compatible, to be able to handle the case where a new value shows up that maybe they weren't expecting. And if it's an enum value, let's just map it to something called undefined. And this is what we do both in the Scala generator, and we also support this in the Java code generator. So on the Java side, it's a Java enum, and the Java enum has an undefined value set. So that's one of the things that we found works well for us. So let me see if I can find there's also I should mention, let me expand this. So in the code generator module, there's also code to generate a play routes file. So this helps facilitate your server-side implementation. So once you've built your API descriptor, you can use this to generate the routes file, and you can embed that into your play app. Let's see, I was going to go find the Java generator just for comparison, but yeah, so these code generators have to be super careful about reserved words in the language that's generating code for. So on the Scala side, we have awareness for reserved words, and the Java generator has a list of Java reserved words. So if you were to define your API in a way that had a field that had a name that conflicted with some Java reserved word, then our generator just knows about it and will do the right thing for you. So it won't ever output broken code. And see if I can find one more thing here. So in the Play side, in the Play code generator, we built a test suite to make sure that the generator is doing the right thing. And see if I can find this here. So one of the test cases in our test suite is to make sure that the code that gets output is syntactically valid code. So we wrote this little function that does the validation. I'll just zoom in here because this code was not obvious, and I could not find this anywhere on Stack Overflow. And I don't even know how I came up with this, but it turns out that in order to programmatically, set up the Scala parser and run the parser and get the list of errors that were found, I couldn't find an easy way to do it. So maybe someone here knows a better way, but there was all this setup code. You had to import scala.tools.nsc. Then you had to set up a bunch of objects. Then you had to set use Java CP equals true. And anyway, then you set up more or less the parser object is here. Then you have to set the parser phase, and then you have to call cancel. And then you have to say new unit parser, and then you say parse. So it took me like days to figure this out, and honestly, it still doesn't make any sense to me. But anyway, so you call this parse method, you get some result back, and that result has a field called error count. And so this test just verifies that error count 0, and that's that. So yeah, that's more or less my conclusion. I did want to mention one other thing here. There's another presentation from a Gilt engineer 2 years ago that really goes into a lot more depth about what the dependency hell was and how much the binary coupling was ruining our productivity. So you can find this on InfoQ, and the video is up there, and there's a bunch of slides all around it. But yeah, that's all I had today. Are there any questions?
So actually I have two questions. First, how would you compare API Builder with tools like RAML and OpenAPI Swagger in terms of specification? And the second question, since you don't have this commons library anymore, how do you share these objects between services, or do you share them at all?
Okay. So the first part was about RAML or Swagger. How is this similar or different? I have not used either of those technologies, so I might not be the best qualified to compare and contrast. I will say that API Builder has support for importing and exporting Swagger specifications. That is something that we think is important to support in our framework. We try to, we have this import-export module, and we actually use the Swagger parser library to make sure that we are parsing their files and then mapping it into our own model. As far as RAML goes, I haven't really looked at it, so we don't have any import or export support for RAML. And then I think your second question was about how do we share the code that is generated across services. It turns out.
Yes, so before you mentioned you have like a definition of product, for example, right? That is shared through the common library across all the services. So now, if you don't have a shared library, how do the services know about this definition of product?
Yeah, so with the code generation that we're doing, typically what a team will do is, if I own a service, so let's say like I work on the checkout system, and I need to call another service that's called the shipping calculator service, and that service has a published API. So I'll generate a client, which basically just gives me the source code for that client. And what our teams do is we just copy that source code into the service where we want to use it. And I kind of understand that might sound incredibly horrible. But we've been doing that for 3 years, and actually it hasn't really caused too much pain for us. But there are times when I want to pick up some new changes from the shipping calculator, so then I just have to go generate a new source file and then copy that into my project. And the way API Builder works, the Scala Generator outputs everything as just one Java source file. So everything just gets embedded in one thing. So when I need to upgrade in my project, I just overwrite one file and commit, well, run tests, commit, whatever. I think there was one or more teams that tried taking the generated source code and then checking it in and then running a SBT build and then publishing artifacts. And I think there are teams that have done that, but by and large, most development in our organization does not follow that practice.
I was wondering if there are any plans to support a standard specification for defining the service methods like proto-buffers, IDS.
Yeah, we are only supporting JSON as the format right now. We have not really discussed supporting other binary formats. I think that our philosophy has just been like to do one thing and do it really well. And I don't know that our roadmap is going to incorporate protobuf in the future. But all right, I think we're going to run out of time. So I will be here at the conference today and tomorrow. So if you have any other questions, just come find me. Thank you.